Welcome to the VRIFY Podcast, a place for interesting conversations in the mineral exploration industry. I'm Steve DeJong, CEO of VRIFY, and joining me today is our CTO and geologist extraordinaire, JP Paiement. JP, thanks for joining me today.
Thanks, Steve, for having me.
So after the unprecedented success of our first podcast episode of 12 views and 3 comments online, we decided we'd do another one. The purpose of today's conversation is, to get to know each other a little bit better, so we don't spend enough time with each other. But actually, it's to jump into some of the more technical elements of what we do. And I'm going to try and pick your brain both on, I'd say, applications of technology, machine learning, and how you see that intersection of technology and mineral exploration, geology as a whole. Okay, JP, why don't we start? Why don't you share with us a little bit about your own background?
Yeah, for sure. Nothing sort of predisposed me to become a CTO in life. I've studied geology. I'm not a software engineer by any means. I didn't know much about software development. I've always been involved with companies that did have a software component to them, though. That was always sort of something that came to be from either just pure luck or maybe it's just foreshadowing of where my career was going. I studied geology in university, did a master's, started working as a core logging geologist. Took me about 2 months to figure out that it's not something I wanted to do. It's just too repetitive for me. I need to sort of constantly be changing environment. I think it's what people call ADHD or something. But yeah, it's so it opened my eyes to basically different things that exist in geology, but like repetitive task is one thing, but I wanted to be more problem solving. So I got a job as a consultant geo out of a company based in Montreal. We did a lot of resource estimation, but also field campaign management. So I started by just babysitting drills at night. I was a nighttime geo, working from 6 at night to 6 in the morning. It was my first job with the company.
I think you have a good story you've told me before about finding your drillers in the bar when they're supposed to be running a drill rig.
Yeah, exactly. So that's one of the challenges of managing people in exploration programs is they're as reliable as the people you can find. So yeah, I walked up into a bar one night, Saturday night, and I was obviously off duty at that point, but the drillers were sitting there having a beer. So it was a really awkward discussion to why they were sitting there. Turned out the drill was broken. They just forgot to call me and tell me that the drill was broken. So there's just waiting for pieces while drinking. So that's an interesting one for sure.
And when you think about, obviously, something about geology kind of intrigued you for you to do it, kind of go to school for it and so on. When you look at geology, there's exploration, there's resource estimation. Like what is the element within it, no pun intended, that really turns your crank? Is it going out there and making a discovery? Is it seeing a deposit become a mine? What element of the industry do you find most intriguing?
Yeah, I like the investigation side of geology. So basically showing to an unknown case or just an unknown area and trying to figure out how what you're seeing on the ground happened and how it happened and how to put a deposit there. So that whole investigative side of geology really sort of drives me and still does today. I've always been really interested by data as well. Again, mostly out of luck, I guess, because when I looked at the courses for different universities, I picked the one that had the least math in it because I didn't want to do any advanced math at that point. It came back to bite me later on where I had to like relearn the whole geostatistics side of things. But I like trying to use data to understand what we're seeing on the ground, and making those connections is really what drives me.
So JP, in 2014, our paths first crossed at Integra Gold. We did the Integra Gold Rush challenge. We acquired this massive data set from 2 old mines that have been shut down forever. I think we spent about $1 million digitizing it, and then we put it online, and what became the Integra Gold Rush challenge, which was essentially $1 million for whoever could go through this data set and tell us where the old timers, when they mined this, missed opportunities for mineralization. Your team, which was led by you and Guy, shout out to Guy there, who after this was the CIM Mining Person of the Year.
I know.
Front page and all. Your team won that competition. And part of your submission was it wasn't just a geoscience-led exploration model that you submitted to it. It was machine learning. It was a combination of machine learning and geoscience. And a lot of the feedback we received on the back of that is it was one of the first time people even saw any sort of application of machine learning within exploration and specifically within predictive models in exploration. So I'd love to hear, that's 2015. We all know machine learning today is very different than it was then, but I'd love to hear your feedback from, how old were you at the time? 33, 34 years old?
Yeah, I was 32.
32 at the time.
Yeah.
Getting up on stage in front of kind of 5 industry titans in a 600 person crowd to pitch a machine learning idea. I'd love to hear just what that was like and essentially the overall response to it.
Yeah, it was really interesting. Like one thing we told ourselves is we couldn't oversell the machine learning side of things because we were pitching to an industry that sort of wasn't basically tech aware, if we want to call it that. They're not necessarily aware of the existence of AI and how we could apply it. So we did a lot of work in the background to make it really credible in terms of geosciences, right? So that was a big part of our submission. And then, we came on and tagged the machine learning a bit late on the program. We didn't initially plan to do it, but when we saw the basically database we built, so we took all of your data and built a big data cube for the whole area. And when we looked at it, we're like, oh, that's the perfect environment for a big data application. And then we started looking into how we could use big data to make predictions. And that's what brought us to machine learning at that time. It was an older version of what we know now. So basically it's a model. The model we use has been around, and AI is not new. Like all of the models we're using right now have been basically inception in 1950s. So it's not like a new thing. Back then, we needed a really big computer to be able to compute it. Now it runs on a laptop just because the computing power is just increasing exponentially. So that was sort of what we did for that application. It was received with, some were really excited, to be honest. Some people came after and talked to us and like, that's amazing. That's a really good idea. A lot of people also came to us and said, why would you use something that's so black box? I don't believe in AI or machine learning application because I don't know how it makes a decision. You can't just throw data in and get an answer. That's not how it works. And that's not how exploration works, which I think to a certain degree was right at that time. Now, like with 10 years after that, I can now explain how the model works way better than I could do back then. Yeah. So that changed a lot.
As we go through this, you're kind of interchanging AI and machine learning. Maybe let's pause there for the people like me. What do you see as like when we talk about AI and its application for mineral exploration and machine learning?
Yeah.
What are the similarities between those two technologies and where are they different?
They're not different at all. Like AI is a broad field of research. So let's say like the goal of AI is to reproduce the way a human brain would make a decision. Obviously, we're not there. What we use to do that are machine learning algorithms. So basically, we have to teach a machine a question and the answer, and the machine trains itself to answer the question. And once we feel like it's trained enough, then you can deploy it. So that's like machine learning. It's part of the field of research that is AI. Yeah. But building that true AI and what people think is AI, I don't even think it's possible. Like there's so many parameters.
It's sort of like right? In some ways it's a sexier term.
Yeah.
But at the same time, it also it's a bit of a promotional term as well.
It is.
Like,
it's 100% used.
We often get asked, like, is this really AI or is it just machine learning?
Yeah.
And the reality is the bulk of the work that we do is machine learning.
Yeah. And like all through the different industry, the tech industry, true AI doesn't exist. It's all machine learning.
Yeah.
Yeah.
So if we look at going back to the submission for that competition specifically, I think it's a perfect example of where you have a massive historic data set that was operated. I think Teck was there for 70 years and Placer Dome for 60 years.
Yeah.
And then the Triangle deposit, which turns out is a lookalike to those two big deposits, was discovered as well, right under their nose. And then since then, Eldorado is now operating the mine there, has now discovered another deposit, the Ormac deposit, halfway between the mill and the mine site. I think it's at 1 million or 1.5 million ounces out as well. Did So, sorry, one question for you. I've always wondered: did the ORMAC deposit show up in your initial submission, or just the target area?
The target area, yeah, for sure. One thing is, you guys, when you submitted the data, you omitted all of the triangle zone.
We blacked it out.
Yeah.
Yeah.
We did find that zone. So for us, that was the first validation because we knew what it was. Like we knew you guys were drilling there. We knew that there was something there.
So you guys discovered triangle, not us.
Well, basically, yeah.
Okay.
Yeah.
Interesting.
And then, the other places that we add in terms of target, ORMAC, I think was one. There's another deposit, a smaller, it's called Plug 4. We also had it as a target. So it was interesting for us to see. I think you guys published a map of your exploration targets a few, 6 months after the challenge. And we could see correlations between where you guys were wanting to explore and what we had come up with in the submission.
I think one of the parts that I found super interesting, and again, I'm not a geo, but I remember going back. So all the submissions were anonymized, so we had no idea. And then we had five sharks judges that were there for the final, but your final presentation at the big event was only 20% of your score. 80% of your score was determined ahead of time, and it was 5 PhD geos who kind of went through everything and then chose which ones got to actually make it to the final stage out of the all the submissions we had. And I actually remember the conversation they were having around whether or not the machine learning component was a positive or a negative. And because it was rooted in geoscience, it made it through the filter. Yeah. But we still see that today, and I think we always will in this industry and every other industry.
I think it's super important too,
to be skeptic of it.
To be skeptic, but also to make sure that what you're doing is rooted in the science you're actually trying to do. Yeah. So it's not like I'm a data science student that just came out in university and said, "Oh, I know all about data science. I can solve that geology problem." I think you need to understand the data, but also the conditions of all of that data deeply to be able to apply AI. And that's what we did with that submission, right? We wanted to show that we were really good geoscientists, good explorers, good geologists. But then we also believed that there was an edge into removing the biases we had as explorers. Because the method we employed, the geoscience method for us, was to rank each cube in our model given our exploration biases, was essentially what we did. So we said, if a cube is within 200 meters of a fault, give a score of 10.
Yeah.
If it's within 200 meters of a fault and inside a certain rock type, then you give a score of 30. So that was essentially just building a lot of bias into that exploration model from our exploration experience in the area. But then what we wanted is to see if the machine was able to either pick up those biases or break those biases, and what were the difference in areas. So what I liked, and the reason why we pushed it through, is because the algorithm we used was finding the same targets we were, but also generating targets that we hadn't generated. And that's where we sort of saw an advantage of using data-driven approaches.
It's interesting you describe it that way, because something like 200 meters from a fault, now sort of in the process that we would go through is you include a fault distance map.
Yeah.
And then have a vision transformer that reads it, but it's essentially the same exercise.
Yeah, exactly. So what we've built in terms of technology at VRIFY works exactly like an exploration geologist would work. So it looks at examples of successes and examples of misses in exploration, and then tries to see where are my successes, where are my misses, what are the conditions of the different grids I'm feeding in, and how does that equate to finding another one.
So do you think 2015 machine learning submission wins this challenge, did you start to think that maybe this is a bit of a turning point or inflection point for the industry, where we'll start to see more? Because there were machine learning and AI type applications prior to that as well.
Yeah.
But this being a higher profile example of just through the competition and so on, did you think that was going to be a bit of a turning point, and we'd start to see this sort of mad rush of people really trying to understand the implications of the intersection of machine learning and geology? Or did you think it was just a blip and
No, for sure. I think that was a turning point just because of the visibility around the event. Other people were using those techniques, but essentially siloed inside companies or inside research papers. So you didn't really get exposed to the industry at large. And that's one thing that's important, I think, in our industry, is to get that level of exposure to the broad public, if you want. So I definitely saw it as a turning point in my career because I just like figured out a way to get more out of data than what I was used to do before. So it drove a lot of my career choices after that, just because I wanted to automate a lot of things, get rid of repetitive tasks. So certainly made a big change for me. And then on the back of that, we started hosting trainings. I think the year after at PDAC, we had a machine learning course for geologists.
Interesting.
I think there were 5 of us teaching it. And it was like not as detailed as a machine learning class we gave last year, for example. But the goal was to start to drive that interest in the geoscience community, but also make sure that people knew the limitation and how you should be applying AI, right? So one thing I didn't want is for it to become a buzzword. That's always something that's bothered me.
Yeah, it turns out it has.
Yeah.
The other interesting thing I think on the back of that, so the year after we did that, we did disrupt mining, which was between Integra Gold and Gold Corp at the time. And the winner of disrupt mining was Goldspot.
Yep.
So Goldspot, which turned into, essentially was the first, I believe there maybe there's others, so I might be wrong on this, but was one of the first kind of machine learning driven targeting applications out there where it actually turned it into a business.
Yeah, but then the team who founded Goldspot were the second place winners of the
Integra Gold Rush, the Integra Gold Rush Challenge.
Exactly.
Fast forward, so in 2023, we built VRIFY more on the data visualization side.
Yeah.
You and I joined forces and said, essentially, you've been kind of playing around in this field in various consulting roles, both as a consultant on the buy side and the institutional investment side as well. Let's take what you've been working on and let's kind of combine it with our technology and our platform and so on. So what are we at today? I think we're at 35, 40 clients on our AI platform.
Yeah, active clients.
And I thought it would be actually kind of interesting just to go through, like you and I both, we spent a ton of time just meeting with geos, technical teams, executive teams, having discussions around AI, machine learning, how it can be used, how it can't be used. We like to say things like garbage in, garbage out for data, all these other applications. We kind of have a bit of a unique perspective. Like you and I collectively in the last 2 years have probably had 200 to 300 conversations with the decision makers at companies around sort of the application of machine learning specifically as an exploration tool.
Yep.
Give me if you had to generalize the overall take on what we do, good or bad, coming from the skeptics or the true believers in what we're doing.
Yeah.
What would your commentary be on that feedback in all these discussions that we've had in the last few years?
Yeah, there's some interesting points that sort of keep coming back on the discussions we have, especially on the technical side. I think like on the C-suite or the exec teams that we speak, there's more of a will to adopt new technology. On their technical side, it's always a bit more of a discussion, which is okay. I think you should be skeptics about new things and sort of try to understand them if you want to use them as part of your workflow. One thing you mentioned is the garbage in, garbage out principle, which I think applies to AI, but to anything. It's like people say that, but if they use garbage data to run their traditional interpretation workflow, they'll still produce garbage in the end, right? It's not because it's a machine that it's not as good as the human. I think like if you have garbage data, you have garbage data no matter what.
Yeah.
There's ways that we can clean it though, and that's the thing is it's not because your data is bad now that it won't get better if you sort of apply different things to it. So that's one thing we've been also discussing with people. And the other big thing is the black box sort of concept around machine learning, right? So one thing we've been trying to do is sort of make all of these models explainable to the maximum. So you're not just relying on like put something in and get an answer and just walk off with that answer. We really want these models to sort of be explainable. And the way we've been selling it to geos is basically by opening the black box on how AI works. And it's super similar to how their decision-making process works in real life. And that's, I think, turned a lot of people around.
So I think one of the realizations that I've had in sort of the work that we've done and just watching you and your team work alongside these companies and at the same time build the technology to do it is everything is a waste of time if you don't treat the data, like if you don't respect the data almost.
Yeah.
In that you don't just, I think we historically put a lot of emphasis, and I think of my own, like how I would pitch what we do and so on, into like we have these great algorithms and we apply all this kind of AI magic to it, and all of a sudden it magically shows you where to drill. Obviously, I'm oversimplifying. What we realized going through the process is the database that we typically get from a company is nowhere close to where it needs to be to actually do anything with. And, and 80% of our onboarding and our time is not spent kind of creating targets. It's actually cleansing data, augmenting data, creating new data sets, finding new data in the public domain. And then from there, it actually gets easier and easier as you go. Would you agree with that?
Yeah, for sure. And that's a big part of, I think, the fact that the data has been collected way before any data-driven application existed. So there's never been a format, there's never been a unified types of sensors in our industry that always collects the same thing in the same format, right? So there is a lot of work that goes into making the data ready to be used by AI, which might not apply to certain industry. If you think of a self-driving car, when they're building the car and the sensors, they build them with the final or the end goal in mind. So like they put on 2 cameras to make sure that they can judge depth and collect the same data and over. Whereas our industry has been collecting data for more than 100 years. And no one thought that AI would be applied until the last 2 years. Right?
I think even back to like the data set for the Gold Rush Challenge, it was Plasterdome and Tech.
Yeah.
2 companies who just never spoke to each other, even though their minds were 500 meters apart. And when you go through the data set, like the way that they calculated gold assays, every
it wasn't
element,
even the same unit.
They weren't using the same rock types in the core logs,
Yeah.
and every single element had to be normalized first, because you can't train something when it doesn't know that these 2 things are the same.
Yeah, exactly. Yeah.
What blows my mind, and it always has in this industry, and like I've been involved in the other side, so I'm guilty of this as well, is that you're out there actively kind of raising money to drill holes, to make discoveries, and in doing so, like no one's data is in a great, like no one is utilizing all of their data, whether it's because it's not cleaned or because there's more data that they're not getting out of it or so on. But we're yet to work, and like VRIFY's 175 companies now. No one's data is in that good of shape. And it's sort of just like the accepted standard in the industry. Like,
I think it is. Yeah.
Does that change?
It's slowly changing. We're seeing it change, but we're also trying to be that vector of change. But I think that might change in the future just because they'll see more application of AI and they'll have to do it at some point.
I think so. And I think it's also as groups like ourselves and others come up with tools to actually kind of automate the cleansing of this data, there's no excuse anymore.
No,
like if I can take a geochem database and a drill database, throw it in, and 10 minutes later I have a completely normalized database, it's pretty hard to justify not doing that.
No, exactly. And with the automation and some machine learning, we can also streamline that process of leveling data and normalizing that data, even if it's from different generation, different assay methods, which in the past you had to do manually and try to figure out which population you had differences in Excel or whatever you used, and manually back calculate all of that. Whereas now that could be fully automated.
So if we're going to pick apart, like as we go through this exercise, I kind of want to pick apart what's actually machine learning and which is just like data, data cleanup and so on. But we just, like one client we just worked with, it's a bigger company, super active. They've had a ton of success. I'd argue one of the kind of bigger discoveries advancing through to feasibility and beyond in the last 3 or 4 years. We just took their database in, and I think the numbers, this is in the last couple of weeks, was 180 hours that we spent.
Yeah.
And it pretty much down the line of cleansing the data, normalizing the data, and then 50% in augmenting the data.
Yep.
And we don't charge by the hour, so it's not like this is us trying to inflate what we do. That's a fixed cost.
We need to do it in order to
go through that. But
software.
I just, as someone on your team shared this with me, and I was blown away that sort of, what is the 180 hours that was spent to get this database? And is it because we need that data in a certain place for it to really truly benefit from things like machine learning algorithms and other things? And or how much of that is just, it's quite a disjointed, fragmented data set that should have been cleaned up anyway, or is it somewhere in between?
I think it's somewhere in between. There is a certain portion, and again, a lot of work was put on the geochem, which is the hardest piece to solve for. And the reason is because 20 years ago, the assay methods we used to identify the elements didn't have the same detection limit. So the leveling of the data is really different. So you have to identify these different types of surveys and try to come up with a way of leveling them, meaning like an equation that's going to take one and produce the same result as the other one. So that's a lot of work. There's still a lot of manual labor that goes into doing that. And the other example we have is they wanted us to sort of work on the geology prediction, so making a data-driven geology map out of it. But when we looked at the geology mapping points they gave us, I think there was like something like 128 different lithologies in there. Just because, again, over the years, people doing the mapping either don't call the same rocks the same names, which is a common thing in geology, just because there's a level of interpretation that goes into naming a rock. And it's also fit to the model of exploration you're doing. So there's so many variables in the final name you're attributing to the rock that two geos could be on the same outcrop and put out a different label.
So
right?
on that, one thing I've always wondered is, as you get more to sort of core logging that's done automatically through kind of core photography and things like that, does that normalize that?
It normalizes the data a lot. And then the names actually don't matter anymore because we just know that
it looks like this.
It looks like this, right? So whatever the name you gave it is sort of an interpretation. It's fit to the model you're trying to build. But then you could change the name and it would change the name across the same lithologies for your entire database, which make things way easier.
Yeah. So one of the things that's been a lot of fun for me to watch is, again, non-technical person sitting on a call and watching a bunch of geos nerd out about sort of results. One of the things that I found fascinating is the results aren't just like, hey, here's a fancy drill target driven by AI over here.
Yeah.
It's, look what I was able to do with your data. I was able to take a mag map using a series of algorithms, create a lineament map, which you had input into what specific type of lineaments we're looking for. From there, a structural complexity map. And all of a sudden, we're automatically generating in a matter of minutes kind of augmented or additional data sets from one source of data. And this is all pre-target generation or anything else. Maybe speak a little bit about that, because I think I've had so much fun just sitting on some of these calls and watching people. We tend to just flip through because we're just trying to get to the results at the end, which once we feed all this stuff into the system, let's see the predictive model that shows up. But those sort of steps along the way are all steps that a geologist can actually, is work that they're probably doing themselves or having consultants do, and is valuable to their own understanding of the mineral system as well.
Yeah, 100%. And that's like part of trying to extract as much value as possible from existing data sets. So one thing I think we believe is also that we haven't been using data to the full capacity historically. So what that entails is basically trying to derive more information out of, let's say, a mag survey. So if you're running a mag survey, you're getting the physical response of the rock, meaning how much, basically it's a proxy to how much iron there is in the rock or how much magnetite. But it also measures things like faults indirectly, just by seeing how some magnetic units are offsetted or breaks in some of those anomalies. And this is really good for structural interpretation, which is a different type of interpretation as the actual rock types that are derived from the iron content. So what we were trying to do is just provide tools for geologists and geoscientists in general to be able to quickly run those assessments. Just because I think there's no single answers to these problems. It's always a range of possibilities, because again, we don't know what made and what really happened. So we have to go with a lot of assumptions. One reason we're automating it and trying to extract all of these information automatically or through algorithms is because it allows you to be super flexible on rerunning it with different parameters and generating basically a range of possibilities from your data, which feeds into your targeting. So instead of like just being what we call deterministic in your approach, where you go, this area is this rock type, here are the faults associated to it, and this is what I think generated my deposit, we'll be able to do, well, these are a range of possible lithologies derived from that data set. These are a range of possible structural method which also leads to a range of possible outcome in terms of how and where you deposit form. And that is way richer. And from there, we're able to just make better interpretation.
So is the deterministic polygonal geology map a thing of the past in your mind from a place of, say I've got an area and it's got 100 points or sample points.
Yeah.
And each of those sample points, I wrote down what kind of rock type it is.
Yeah.
And then based on my observations, I sort of draw my
context.
and over here it was this type of rock. And on the other side, but it's very binary. It's either this or this.
Yeah, exactly.
But the alternative, say that I have 30 lithology types within that map. The alternative, what you're describing is I would need 30 different maps because I would have a predictive map for each lithology.
Yeah, essentially.
But that's a human can't really, like, is the reason we're using polygonal geological maps a constraint of our own ability to process it? Or is that just because we haven't had technology, so we may as well do it that way, or
it's
somewhere
a bit
in
of
between?
both. Like when I started my career, we were still drawing like geological maps on paper using crayons or colored pencils, just because there wasn't enough computing power in a computer to generate a map. Or if we did, it was really heavy and really tough to modify. So it's our limitation as human to understand all of the inputs that goes into making that decision and representing it, for sure. But it's also just a factor of the technology that was available. Now with the computing power we have, what we're able to do is generate a probability map for each lithologies on a cell by cell basis. So instead of saying in between those 2 points that I know, let's say like I've mapped 2 granite points, I don't really know what's in between them. I know that one outcrop I saw 500 meters from the other one is the same rock, but what's in between is an assumption or it's an hypothesis, right?
Yeah.
So you're not 100% sure. So that's why I think moving to probabilistic approaches makes more sense, because it builds into the factor that you're not entirely sure what's going on between the points of information you have. So you're deducting information, but it could be either a granite or it could be something else that's observed in the same location, right?
So I'm heavily biased on this point, coming from like a background where a discovery was made right next, like literally under the nose of 2 old mines.
Yeah.
But when you describe that to me, it just continues to validate what I believe is there's going to be a crazy number of discoveries made in areas that we've already looked at. For one of the reasons might be because we had mapped it all of this, and by mapping it of this rock type, we just kind of blew the whole thing as like, or sorry, wrote the whole area, wrote it off because like that's not the type.
Yeah, exactly.
And whether we are right or wrong on the rock type, maybe there actually is mineralization within that rock type, or maybe that rock type stops on 2 feet on each side of that granite, and it's a whole different unit that
100%. Yeah, it could
that
be.
comes through there.
Yeah, exactly.
Which I think like when and you and I have had lots of conversations about this. I think when we think about machine learning, it's just to challenge bias. It's essentially to like ensure that bias isn't bad. Bias is a result of experience, and like a lot of people have a lot of experience finding minerals, but we should always be challenging our bias, because I think that's where that's
how science evolves, right?
Exactly.
Like if you're not challenging your preconceived ideas, you're not challenging the science, and so you're not moving forward. So I think it's just a tool to accelerate those questions and accelerate the change and evolution of the science behind how we find mineral deposits.
So the way it was kind of described to me, because you and I both have been in a lot of conversations where we've just flat out been told there's no application for machine learning in our industry. It's based on trying to experience and knowledge and so on. An analogy I've been told by someone really smart that I really like, but I'd love to hear your take on, is you have to think of like the discovery or the exploration process similar to solving a murder case, in that we have found minerals for years. There's lots of mines, there's lots of metal in the world because of we found minerals. So obviously what we're doing kind of works.
Yeah.
And a lot of this was done, almost all of it was done without any machine learning or AI.
No, for sure.
But we've also solved a lot of murder cases over the years. When we introduced in the mid 80s, when they essentially unlocked DNA testing, it's because we've solved murder cases in the past is exclusive from the fact that we should go back and apply this new technology and look at every single case we've ever looked at.
Yeah.
And it's completely illogical to think we've already looked at that case, it's closed, but there's no reason to, even though we have kind of genetic material that we could use, that we shouldn't go back and look at it.
Yeah,
So
100%.
I'd love to hear
Yeah.
it makes a lot of sense as a non-technical person to me, like, and that's how I think about a technology like this. It's not like we're doing it all wrong. It's literally the introduction of something new that allows us to have insight into solving a problem that we were solving a different way before because of the limitations of the tools we had.
Yeah, for sure. And I think the analogy works really well just because investigation into murder is mostly deduction based. So you look at somebody's wound and it's like, oh, that person was shot. I am now looking for a gun. And then you sort of make a series of deduction going through what you're observing. And it's the same thing in geology. You basically show up to a case, it happened, and then you're sort of deducting what happened to lead there and then trying to find the same conditions elsewhere. It works. It's not that it doesn't work. I think it works for some cases, or you'll probably be able to find a lot of cases that are similar to this one, but you're probably also missing subtleties in other cases that were slightly different, or that you might think you've solved, but when you look at the full data scheme, maybe there's something you missed in the signal that is seen pretty close to your property that you never thought of investigating prior. So yeah, I think it's a really good analogy.
I'm going to start taking credit for it.
Yeah.
You made a comment earlier about AI being a black box.
Yeah.
And when you think of sort of the tools and the software that we're developing, how does that prevent it from being a black box? And I guess to back that up a little bit, why shouldn't AI be a black box?
I think it goes to the education purpose. We've had several discussions with people that are way smarter than I on the data science side. I still believe we need to open the black box because people are still skeptic about the technology, and that will drive adoption. However, people aren't asking how ChatGPT works. Like, I've never seen a user of ChatGPT ask like ChatGPT, like, why does it work? How does it work? It is a black box. You're asking a question, you get an answer. No one's actually understanding how that answer comes around. But since it works, people don't really care about the black box. So until we have a lot of proven successes in AI application to exploration, people will ask how it works. I think once you get a critical mass of discoveries that are sort of data-driven or insight-driven by AI, people will stop asking. But in the meantime, you do have to educate the public. And I think that's something super
I think one of the things I found most interesting is to see the results. Hey, you should look over here. This thing lights up like a Christmas tree.
Yeah.
And when you actually look at the analysis, oftentimes it's kind of obvious. And it's not, and I don't mean this as a criticism of the team that should have seen it and didn't see it. It's literally because it was, the geophysics anomaly in this corrupted file that hasn't been looked at 20 years next to a rock sample that was kind of sitting in a different coordinate system.
Or a different database altogether.
Or a different database.
The industry is notorious for like people having parts of the data on their personal computers.
Totally.
So sometimes we run compilation and we show the results to clients. They're like, oh, you haven't used these soil grids.
Yeah.
And we're like, well, we never got them. And some geo will be like, yeah, I have them. They're on my computer.
Yeah.
So like just being able to combine all of the information into one data space is probably 90% of the winning battle,
which is,
right?
and it's funny because I've had discussions before. It's like, well, that's not really AI. And it's like, well, if you're outcome oriented and it results in a discovery, whether it was data cleansing kind of, and just an analysis in the back of that versus like how much credit you're actually giving to the underlying algorithm, does it actually matter?
No, exactly. And it might be just a factor of like AI being the excuse to really put all your data together and look at it in one spot.
Yeah.
Like that might just be the excuse, right?
Yeah. So what do you say to the person who is, and there's a lot of people, again, who have a ton of success in this industry, making discoveries, finding minerals. What do you say to someone who just says, like, I just don't need this. I kind of, like, my team and I have been doing a great job finding minerals. We found deposits, we built mines and so on.
It's a hard answer, to be honest. If they're successful and they find mines, it's sort of true that they don't need it. However, they could be leaving behind ground that might have deposit on them. So they could be losing without even knowing. So it's a good sort of due diligence tool on your exploration. So you could still find deposit, but what if you just used AI to make sure that the ground you're dropping or properties you're letting go or claims you're not renewing are actually really not good, just in case you missed something, right?
Yeah.
It would be the equivalent of a doctor not using a diagnostic test because they've been thought to find cancer one way.
I know it's sort of
wouldn't want to make sure that there's nothing.
You're kind of describing an audit. We just don't it's not the it's not the coolest word to use to describe your product, but it is a bit of an audit of I want to make sure that I utilize every single data piece to whatever decision, whether it's acquiring ground, dropping ground, or putting a drill hole in.
And then for the decision makers, it's also an audit to your technical team. You can challenge for the first time, a non-technical person can challenge their technical team. And I think there's a lot of benefit in that because you're not solely relying on one source of information.
Yeah. So what's as we start to see more proof points, and proof points can be a lot of different things as we've seen. Proof points can be a trend that you've identified, it drifts off your ground and ultimately results in you staking more ground. It can be sort of identifying things that you can go and sample in the field and find out there's outcrop there that you didn't know about or a new target. And then obviously kind of the big one we're all going for is the drill hole that results in the new discovery. When you think about where all of this goes, 6, 12 months from now, and I don't mean from a place of our specific software, when you think of where the industry is going, what's your prediction on are we going to find ourselves in the same place 12 months from now, where the level of skepticism, are we going to have enough proof points of an industry, of the applications and of this technology? Are we going to be kicking doors down to get as much sort of machine learning into our exploration programs, or where do we sit as an industry, say 12 months from now?
Yeah, I don't think we would benefit of just broadly, blindly applying machine learning to everything we do. I'd be lying if I said that was the my end goal or where I would see the industry. I think there still needs to be a certain level of skepticism into what we do, just because we're such in a unique spot in terms of data quality, the level of interpretation and models that we feed to models. Because one thing that we can't hide is the fact that we're feeding models to models, and at some point there is some fallacies in doing so.
Yeah.
So I don't want to sort of go and blanket apply AI to everything the industry does. However, I'd like the industry to start moving forward. And it's mostly on the fact that I want the industry to be metric driven more than it is right now. So instead of just believing a circle on a map, start thinking and questioning around what is the probability, what is the likelihood, what is the risk.
I'm assuming you don't mean that either or. They should follow metrics versus what they do today. It's more layered on top of what
it is, 100%. It's like using a diagnostic tool on top of the work you're currently doing. So just making sure that what you're doing is done to the best it could be. Yeah.
And then also, I guess the obvious, if you can apply metrics, you can prioritize. It's hard to prioritize circles in more exciting, less exciting.
Oh no, exactly. And it's the person who screams the loudest will win that argument, right?
So something we saw we have a big team of developers and product people and coders and geologists and everything at VRIFY. But something we saw, say 2 years ago, is as AI coding tools were starting to be introduced, a lot of hesitation from coders who, we have very good coders in our team and had this conversation with a lot of other tech companies as well. It's just a hesitation. I've been doing this my whole life. Do I really need this coding tool? It's kind of clunky. It's sort of it ends up with code that I just have to go back and fix anyway. It's not that good, and so on. Fast forward 2 years later and find me a tech company whose coding team is able to survive without using coding tools.
Yeah.
So when you and I, we did a tech conference, or we attended a tech conference in the summer, I'd say we did probably 30 meetings. And one of the questions we asked to all these investors, so we could make this point, I think, for the most part, is would you ever do you look at companies, or do you look at how a company is embracing AI tools to increase the velocity of its or the productivity of their coding team? And every single one of those investors said, yeah, of course, it has to be a core part of their strategy.
Yeah.
Otherwise, you're just essentially kind of hamstringing yourself. You're shooting yourself in the foot to say, I'm not going to use these tools, but those that I'm competing with are, and they can get 2-3 times as much out of the same amount of people in the same budget.
Yeah, and so, beyond just the gain in productivity, I think it just frees a lot more time for the user to think and critically think and problem solve more,
exactly.
Right? So you're not spending your time actually writing the code, but you still have to know what function you're trying to build, what are the inputs, what are the outputs you're expecting, how you want it to function internally. The only thing it changed is you don't actually have to write every line or every letter of that code. And it just allows you for, I think, more creative time.
Yeah,
and it's the same in geology, right?
And people think like, oh, now there's going to be 50% less coders in the world, but like there's no upper boundary to the amount of coding that needs to be done.
No,
it's more like we can create 2-3 times as much stuff, and we can do it a lot quicker.
Yeah.
So would you agree that like when I think of that sort of 2 years ago in those conversations versus where it sits today, do you think? And this, I'd say this is my theory, but do you think geology and geologists and the exploration industry is kind of sitting where that was 2 years ago, where these things are starting to show there's a ton of criticism and skepticism around them.
Yep.
But as they start to prove out, people are going to realize what you described. Oh, this allows me to kind of automate, accelerate a lot of the things that I might be trying to do manually already and spend more time being creative. And then the second part to that question is, do we ultimately find ourselves in a position where investors are just saying, of course,
yeah,
like I do not want to invest in a company who I don't know has 100% data utilization, hasn't gone through data augmentation, and ultimately isn't kind of using hand in hand with its traditional exploration approach, some sort of technologically driven strategy.
Yeah, no, that's, but I think that's a chicken or the egg question. Is like, do we want the investing community to drive that adoption, or is the adoption driven by the exploration and then leaks into the investment community? Is something I'm not sure again, right?
Yeah.
Because you would want the investors to be aware that if a company is not using somewhat of a AI or a data-driven approach, there should be a problem, right? So if it comes from them, that's going to force the industry to move quite faster. I still think that we're probably moving towards a world where there's a lot more adoption for sure. The level of skepticism we see, or the level of questioning, is really important though. I think the next 2 years or 3 years or 5 years are going to be important, because that being skeptic or sort of questioning how it works just allows you to improve the process.
Totally. Versus blindly following an algorithm, which we didn't know is hallucinating for whatever
100%.
reason.
And that's like, basically that's how the coding tools built, right? Is like through that reinforcement learning, they were able to just improve them. And now they're like, you can't go without them, right?
It's interesting, the chicken and the egg. I think, so personally, I think it's going to be through adoption of the industry. You have your first movers who are more willing to adopt. Through that, you're going to have enough kind of quantifiable proof points, case studies that you could point to of how it works. And then I think what's going to happen is sort of adoption is going to accelerate. And then I think you're also going to see, because exploration as a whole is reliant on investors continuing to fund it, I think it's going to be both, personally. But I do think that sort of after seeing the AI coding world go through it, I think we're just 2 years behind. And 2 years from now, personally, and obviously I'm very biased based on what we do for a living, I think you're going to be hard pressed to find an exploration team that doesn't have an AI-driven element of, I don't mean replacing it, but an AI-driven element of their exploration strategy.
Yeah, and even, we could just simplify it to a data-driven approach to decision, right?
Yeah. Okay, great. So the whole purpose of this, I think, is like you and I we're in so many super interesting conversations with companies, with investors, as we share results and we share insight. Some of it's just from cleaning up the data. Some of it's the data augmentation. Sometimes it's the targets we generate. The whole purpose here is, I feel like the more that we can share of these conversations with the industry, the better the industry is going to be in a place to understand both what we're trying to do as a business, but just how AI and technology and all of this work that companies like VRIFY and others in our space are doing to bring mineral exploration into the next phase.
Yeah, and I think it all goes through technology adoption. That's where the real thing is there was a big push towards technology adoption when GIS software became the norm. And that's when I was in school in the 2003 to 2006. I was like emergence of GIS, right? And like it took a while to move them towards that. I think we're into another inflection point right now. We're probably just seeing the start of it. But adoption of that new technology, I think, would be beneficial to the industry for sure.
Yeah. JP, thanks for the conversation. I do have to ask, did you even watch the first one?
I didn't.
No. Thank you. So
I'll watch this one though. It's going to be super interesting.
I honestly, I think these conversations are super important. I feel like you and I both have a role to play to just share what we're seeing. Obviously, we're kind of building software that we want to see the entire industry using. For anyone interested in what we're building, what we're doing, check out our website, like, subscribe. I don't know what you do with a podcast these days, but we're going to try and keep having conversations like this. If there's things that really jump out through the conversation that JP and I are having, let us know. We're happy to bring on speakers, and our whole objective in all of this is we are obviously true believers that technology is going to play a role in where the exploration industry goes from here, and we'll do our best to share that with the rest of the world. JP, obviously watching two guys who really believe in exploration and the role that AI and machine learning is going to play in that is one thing. I think what we need to do is we should put you up against maybe not some skeptics, but let's think of who are the most successful geologists out there, traditional geologists out there, because I would love to watch you go toe to toe and debate kind of some of the things that we're doing, some of the more traditional approaches, and see where it all goes.
Yeah, I don't even think it's going to be a fight. I think
you'd actually agree on a lot of things.
Oh, we'd agree on a lot of things. It's just a way of seeing the future that might be different.
So anyone watching this podcast, any of the 15 viewers out there, if you have any suggestions on who those people might be, let us know. We'll reach out, and I think it would be a fascinating conversation.